Morning. In today's class, we will study about electric field and electric field intensity due to line charge. So we will move ahead. So you know that an electric field, electric field you have studied in your lower classes. It is a region around a charge in which it exerts a force on any other charge located in that region. So you can see from this, so there is a charge Q1 here, and you have many other charges Q1, Q2. So it's all the charges are named as Q2. So F2 will be the force acting on Q2 due to the charge Q1. So now, so how to calculate that force we have already studied in the last class. That's by using the Coulomb's law. So what is an electric field? The region around a charge in which it exerts a force on any other charge located in that region. So that is what we call as electric field. So electric field and electric force. Coulomb's law വെച്ച് നമ്മൾ ഫോഴ്സ് പറഞ്ഞു. ഇത്രയും കാര്യങ്ങൾ ക്ലിയർ ആണോ? So now we will move ahead to see what is an electric field intensity. So we can write. So we'll write an equation for the force. നമ്മൾ already എഴുതിയാണ്. So F2 is equal to force acting on the second charge. Force acting on the second charge by the first charge. So that is F2. So you know by Coulomb's law the equation will be F2 is equal to Q1 Q2 divided by 4 pi epsilon 0 into R12 the whole square into A12. So this can be the distance. So if you take this as A12 means this will be A12 the directional vector, and this distance will be mod of R12. So all these things you know. So this is a force. This is the force acting on second charge by the first charge. So this we have seen by Coulomb's law. So now we can write. Are you listening?
Yes, sir.
Okay. So F2. So now we'll bring the Q2 to the other side. So F2 divided by Q2 is equal to Q1 divided by 4 pi epsilon 0 into the distance, that is R12 the whole square into unit vector A12. So unit vector A12 we are not writing it as vector divided by the modulus. So you know, we already know. So you can see that in the right hand side we have written force per coulomb. So F2 divided by Q2, that is force per unit charge or Newton per unit charge. So എന്താണ് F2 എന്താണ്? Force per unit charge. അല്ലെങ്കിൽ you can also write it as Newton per unit charge. അല്ലെങ്കിൽ Newton per coulomb. So charge unit you know. So this force per charge it is what we called as E2, that is electric field intensity. Electric field intensity. And so the unit can be force per Newton or Newton per coulomb, or also we give the unit volt per meter. So that is also you will derive when you move ahead. So you can see that the force, you know, force is actually a vector quantity you have seen in the last class. Similarly, the electric field is also a vector quantity. So because it has magnitude as well as it has the direction also. So this is the magnitude and this is the direction. The unit vector, it has the direction. So that is the electric field intensity. So we have already seen what a force is by Coulomb's law. That is when two charges are separated by some distance, so they experience a force. So, but the same charge will have an electric field around it, so that the force, so that the charge kept on its vicinity will experience a electric field intensity. So that is given by force per unit charge, that is F2 divided by Q2, that is 1 by 4 pi epsilon 0 Q1 divided by R12 the whole square into A12. That is electric field intensity. Clear or not? What is electric? So you already studied in physics these things, so it should be clear for you. Is it clear, or anybody has any doubt?
Okay.
Okay. So we can write it like the electric field intensity. The electric field intensity is the force experienced, please write down along with me, is the force experienced by a unit positive charge kept in the vicinity of another charge. So the force experienced by unit positive charge kept in the vicinity of another charge. So that is electric field intensity, electric field. So that's a vector is equal to 1 by 4 pi epsilon 0 into Q divided by R12 the whole square into R12 the vector, that is a position vector, divided by modulus of R12 volt per meter. So that is electric field, and epsilon value you know. So I think last class something I want to correct is 1 by 4 pi epsilon 0 is equal to 9 into 10 raised to 9. ഇങ്ങനെയാണോ നമ്മൾ ലാസ്റ്റ് ക്ലാസ്സിൽ എഴുതിയത്?
അല്ല സർ,
അല്ല, അതാണ് അത് epsilon 0 is equal to 8.85.
സർ 1/36
അതെ 8.854 raised to minus 12 farad per meter. എപ്സിലോണിനെ നമുക്ക് അങ്ങനെ റെപ്രസെന്റ് ചെയ്യാം, അല്ലെങ്കിൽ നമുക്ക് 1/36 pi into 10 raised to 9 farad per meter എന്ന് എഴുതാം. അല്ലെങ്കിൽ ഇതെല്ലാം കൂടെ ഒരുമിച്ച് ഇറ്റ് ഈസ് ഈക്വൽ ടു 9 into 10 raised to 9. ഈ ഒരു റിലേഷൻ നിങ്ങൾക്ക് ഞാൻ തന്നില്ലെന്ന് തോന്നുന്നു ഇന്നലെ അല്ലേ? I think I missed this relation. So while doing the problem we can use this also. Okay ആണോ? So you just multiply and see whether all these things are equal or not, so then you can understand. So okay, so this is our relationship. So this is our main equation for electric field. Main equation for electric field is this one. So we can go for a graphical representation also. So if this is the electric field, and if this is the distance R12, so you can see that electric field is inversely proportional to the square of the distance. So inversely proportional means the graph will square. So it is not linear, so the graph will be like this, inversely proportional to the square of the distance. That is, E is proportional to 1 by mod of R12 the whole square. That is the distance. Clear or not? Is it clear?
Yes, sir.
Okay, so now we have talked, it's about now we have talked about two charges. So if we have more than one charge, I'll go to the next slide. So if we have more than one charge, so if we have more than one charge, for example, it's a point P here, and you have charges Q1, Q2, Q3, and Q4 here. So these are all the distances between them. So Q1, Q2, Q3, Q4. Please write down along with me. So you know that there will be electric field E1, E2, E3, and E4 all. Because of these charges, there will be electric fields also, right? E1, E3, and Q1 also here. So this will be E1, E2, E3, and E4. So there will be electric field. So how to find out the electric field at a particular point P due to all other charges? We need to find out the net electric field. So you know that E1 will be equal to F1 by Q. Similarly, E2 will be equal to F1 by Q1. So E4 will be equal to F4 by Q4. So you know, individually there will be electric field intensity. So what will be the net electric field? The net electric field will be, the electric field E is equal to 1 by 4 pi epsilon 0 sigma k is equal to 1 to n. So if it has n number of charges, here n is equal to 4, qk divided by rkp the whole square into akp, that is the direction. This k can be 1, 2. Qk എന്ന് പറയുമ്പോൾ it is the kth charge. Are you listening? Are you understanding? Qk means the kth charge. So this is our point P. നമ്മുടെ point P യിലുള്ള total net electric field. So what we have find out is the net electric field at point P due to the other charges, that is Q1, Q2, Q3, Q4. So that is a net electric field. So here we have taken n is equal to 4. 4 number of charges. Is it clear?
Yes, sir.
Okay. So now what we have talked is about point charges. അതായത് ഒരു സിംഗിൾ പോയിന്റ് ചാർജ് ആണ്. പോയിന്റ് ചാർജ് എന്താണെന്ന് I explained to you in the last class. Now, if the charges are distributed, consider a case when the charges are distributed. Consider a case when the charges are distributed. So charge distribute ചെയ്യുമ്പോൾ എന്താണ്, നമ്മൾ ഓൾറെഡി പഠിച്ചതാണ്. ലൈൻ ചാർജ് ആവാം, അല്ലെങ്കിൽ സർഫസ് ചാർജ് ആവാം, അല്ലെങ്കിൽ വോളിയം ചാർജ് ആവാം. ഒരു ലൈനിൽ മൊത്തം ഇങ്ങനെ ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യുക, അല്ലെങ്കിൽ സർഫസിൽ മൊത്തം ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യുക, അല്ലെങ്കിൽ ഒരു കംപ്ലീറ്റ് വോളിയത്തിലുള്ള ചാർജസ് ആവാം. So first one is line charge density. So now we have what all we have seen till now is all about point charges. So now we'll be talking about line charge. So we'll consider a line here. So we'll consider a small area, small length dl. So always we can do like that only. Small length dl, and we have a particular. So we need to find the electric field intensity at a point P due to the line charge dl. മനസ്സിലാവുന്നുണ്ടോ? We need to find the electric field intensity at a point P due to, നമ്മൾ ഇത്രയും നേരം എടുത്തത് these are all point charges, Q1, Q2, Q3, Q4 all point charges. Now we are talking about a line charge. മനസ്സിലാവുന്നുണ്ടോ? So ഈ ലൈനിൽ മൊത്തം ചാർജ് ഉണ്ട്. അപ്പോൾ നമ്മൾ എന്താ ചെയ്യുക? We will take a small distance and then we will just integrate that. So for that we need to we need to study about a term, that is rho L അല്ലെങ്കിൽ lambda. ഇതിനെയാണ് എന്താണ് ലൈൻ ചാർജ് ഡെൻസിറ്റി എന്ന് പറയുന്നത്. That is rho L is equal to dq divided by dl. അതായത് ചാർജ് പെർ ദാറ്റ് മച്ച് ലെങ്ത്, ചാർജ് പെർ യൂണിറ്റ് ലെങ്ത്, അതാണ് ലൈൻ ചാർജ് ഡെൻസിറ്റി. അങ്ങനെ വരുമ്പോൾ വാട്ട് വിൽ ബി Q total? Q total will be equal to integral rho L into dl. So that is about line charge. Okay, and now we will see surface charge also. So second one is surface charge density. നിങ്ങൾക്കറിയാം സർഫസ് ചാർജ് എന്ന് പറയുമ്പോൾ ഒരു സർഫസിലുള്ള, സോ നമ്മൾ ഡി എല്ലിന് പകരം ഡി എസ് എടുക്കും അല്ലേ? മനസ്സിലാവുന്നുണ്ടോ? ആർ യു ലിസണിങ്? ഓക്കെ. സോ നമ്മൾ എന്ത് ചെയ്യും? നമ്മുടെ ഒരു സർഫസ് എസ് ഉണ്ട്, അപ്പൊ ഇത് മൊത്തം ചാർജ് ആണ്. അപ്പൊ അതിൽ നമ്മൾ എന്ത് ചെയ്യും? വി കൺസിഡർ എ സ്മോൾ ഡിസ്റ്റൻസ് റോ എസ് ds, and rho s is the surface charge density, and we need to find out the electric field at a point P. So at a point P, so we need to find out the electric field. So എന്തായിരിക്കും? Rho s will be equal to dq by ds. So what will be Q total? Q total will be equal to integral over s rho s into ds. So Okay, integral rho s into ds. So നമുക്ക് അവിടുത്തെ electric field നമുക്ക് എഴുതിക്കൂടെ. Electric field is equal to integral over s rho s divided by 4 pi epsilon 0 into r square into ds. അപ്പം ഇലക്ട്രിക് ഫീൽഡ് എന്ന് പറഞ്ഞാൽ അവിടുത്തെ റോ എസ് എന്ന് പറഞ്ഞാൽ അവിടുത്തെ സർഫസ് ചാർജ് ഡെൻസിറ്റി. ഓക്കെ, സോ ഇത് നിങ്ങൾ യു വിൽ ബി ഡിറൈവിംഗ് ദിസ്. സോ നിങ്ങൾ ഈ ഇതിൽ പഠിക്കുന്നത് ഇലക്ട്രിക് ഫീൽഡ് ഇന്റൻസിറ്റി ഡ്യൂ ടു ലൈൻ ചാർജ്, ഇലക്ട്രിക് ഫീൽഡ് ഇന്റൻസിറ്റി ഡ്യൂ ടു സർഫസ് ചാർജ് ആൻഡ് ദെൻ electric field intensity due to volume charge. So in detail നമ്മൾ പഠിക്കും. So now I am giving you an introduction. So now we have the volume charge density. So ഇവിടെ same way. So നമ്മൾ volume വരയ്ക്കുന്നൊന്നുമില്ല. So rho v is equal to dq by dv. So what will be dq? dq will be equal to rho v into dv. So q total is equal to integral over v dq is equal to integral over v rho v into dv. So q total is equal to integral over, sorry, same thing only, rho v dq is equal to integral over v rho v dv, same thing only. Okay, so far we have seen what is electric field intensity, and then we have derived the formula and all, and we have found out that these force per unit charge. Then we found out the graph and all. We studied about that. Then we defined electric field intensity is the force experienced by a unit positive charge kept in the vicinity of another charge. So initially we studied with two charges. And then now here we studied the net electric field happening at a particular point when it is surrounded by many charges. So n number of charges means it will be 1 by 4 pi epsilon 0 sigma k equal to 1 to n qk by r qp. So all these terms you know, q is charge, qk is the kth charge. Okay. So now after studying electric field intensity for point charges, we need to study about cases when the charges are distributed. That is in case of line charge, surface charge and volume charge. Is it clear? ഇത്രയും കാര്യങ്ങൾ ക്ലിയർ ആയോ? സോ ഇനി ഈ ചാർജസിനെ പറ്റി ഇൻ ഡീറ്റെയിൽ നിങ്ങൾ പഠിക്കും. സോ ഇവിടം വരെ ഇതുവരെ പറഞ്ഞ കാര്യങ്ങൾ നിങ്ങൾക്ക് ക്ലിയർ ആയോ?
Clear answer.
Okay. Okay, we'll do one problem and then wind up. So please write down the question along with me. It's a very small question. Two small, but you need to think also. Two small identical conducting spheres. Two small identical conducting spheres have charges of -1 nanocoulomb and 2 nanocoulomb respectively if they are brought. So this is our second question. If they are brought in contact, so if they are brought in contact and then separated by 4 centimeter, what is the force between them? Please try to do this. What is the force between them? So equations and all you know. Just try doing this. So this is a very nice question. You can check your understanding. Actually, this checks your concentration. So you have Q1 is equal to -1 into 10 raised to -9 coulomb. Q2 is equal to 2 into 10 raised to -9 coulomb. So force, you know, force is equal to Q1 Q2 divided by 4 pi epsilon 0 into r square. So r is given as 4 centimeter, so that you should convert to meter. 4 into 10 raised to -2. Okay. Is there anything that we need to do? Although Q1, Q2 substitute madio. What do you say?
They are not in contact.
They are both in contact and then separated. Appa Q1, appa charge, charges what will be the charge? One positive charge or negative charge?
0.5.
It will be 0.5. So the charge will be Q is equal to Q1 plus Q2 by 2. Very good. So it is equal to minus 1 into 10 raised to minus 9 plus 2 into 10 raised to minus 9 by 2. So it will be 0.5 nanocoulomb. മനസ്സിലായില്ലേ? അതായത് ഒരു പ്ലസ് 2 മൈനസ് 1 ഒരുമിച്ചാക്കി കൊണ്ടുവന്നപ്പോൾ അത് 1 ആയി. എന്നിട്ട് അതിനെ സെപ്പറേറ്റ് ചെയ്തപ്പോൾ 0.5 ആയി. സോ അതാണ് ചാർജ് അങ്ങനെയാണ് വരുന്നത്. സോ നിങ്ങളത് യു ഷുഡ് തിങ്ക് അബൌട്ട് ദാറ്റ്. ഓക്കെ, സോ നൗ ഇറ്റ് ഈസ് ഡയറക്ട്ലി 0.5. സോ ഇവിടെ വെക്ടർ ഫോമിലൊന്നും ഒന്നും പറഞ്ഞിട്ടില്ല. സോ യു ജസ്റ്റ് ഡോണ്ട് കൺസിഡർ ദ വെക്ടർ ആൻഡ് ഓൾ ബിക്കോസ് നത്തിങ് ഈസ് ഗിവൺ, ദ കോർഡിനേറ്റ്സ് ആർ നോട്ട് ഗിവൺ. So 4 pi into 8.85 into 10 raised to minus 12 into 4 into 10 raised to minus 2 the whole square. So I think these type of questions you might have done in your school, right? This type of questions for Kerala entrance and all. I think you might have done this type of questions.
Yes, sir.
Yes, that's right. So these are all, these type of questions will come for GATE exam also, competitive exam, and all these type of questions will come. So today I am winding up. Okay, thank you.